Good morning and good evening. I am Tuğba Sarıcaoğlu. Thank you, Elif, for introducing me. I'd like to thank Erythrae for this opportunity for me to present my research today. I'm going to present a digital archaeology practice that I studied during my PhD. My background is in architecture, and I've been interested in computer science and archaeology since before even I was an architecture student. Today, I'm going to give you a short introduction, and after that, the scope, case study, and the conclusion parts of the lecture will follow. Cultural heritage, particularly in this case, archaeological heritage embodies tacit and explicit knowledge and information. Heritage information and knowledge acquires safeguarding strategies to be sustainable. In architectural conservation field, that strategy corresponds to architectural conservation actions. In this research, a novel, fully data-driven conservation action process will be introduced by implementing digital heritage methodology in archaeological heritage, and the novice concept of HBIM will be discussed. Currently, the architectural conservation actions follows international scientific regulations and national cultural heritage legislations. Although every country and state has their own approach and terminology, the main workflow, as shown in this table, generally these actions are practiced in two parts: first recording, then intervention. Typically, architectural heritage conservation process follows symptom to treatment methodology as the main approach. Although this approach works in the field, there are some issues regarding the heritage information management, particularly for its integrity and its sustainability when it comes to archaeological heritage. For example, using 3D capturing surveying tools and not implementing it holistically to the project other than as 2D drawings and cool 3D visualizations, and repeating technical labor as well as non-transparent decision making are, to name a few of these problems. These problems particularly evident on archaeological heritage. The main reason behind it is that the archaeological heritage embodies heterogeneous information as well as multi-scale spatial and temporal context. In this study, I developed a methodology which consists of 4 modules. Each action module has their own process and adopt the data metamorphoses. In result, we have data-driven, fully transparent, and more democratic heritage information management system. I'll be explaining these modules individually in the case study section of the lecture. Before I start to narrate the data-driven conservation process, I'd like to introduce you the ancient city Erythrae in Izmir. Research has suggested that this site has been settled since the early Bronze Age, and Erythrae is one of the 12 Ionian cities of the Asia Minor. The excavation campaigns have been conducted since 1965. Also, the ancient city is occupied by a living settlement, Erythrae, a village that makes the archaeological site quite multi-temporal and multi-layered place. The Heroon is situated north of the city near to the theater. Here the theater and the Heroon. And it is discovered in 1977 by Professor Akurgal. Heron buildings has been related to hero cults, according to the literature. And they are basically shrines or tombs of the community's heroes. The Heroon Erythrae is dated to 340 BC, according to the script number 151. However, other than dating information, there has not been any other detail referencing the Heroon. Currently, the remains are located on a private property. As a result of that, there is legal limitations as to convey any excavation work. There are also some stone blocks, 156 of them, surrounding the in-situ remains. And in this research, both the Heroon and the stones have been studied. The data-driven conservation has 4 modules, as I said before, which are data acquisition, data processing, information management, creation, and their own separate actions. This process fosters not only conventional conservation actions and the contemporary state-of-the-art ones, but also the raw data to metadata, structured information, raw data to structure information progress, and their documentation, a new concept of paradata, hence the name. I will now illustrate all 4 modules within the Heroon study. First module is data acquisition. In that module, heritage experts capture both physical data and conduct research on the assets, archival, historical, and such like theoretical data of the asset. In Heroon's case, the 3D surveying is done by both terrestrial laser scanning, which is financed by the excavation team, and ground-based photogrammetry. The laser scanning used only for the in-situ Heroon, and the photogrammetry is done for also the stones individually. For this module, I also designed an inventory system tailored to the Heroon, and the excavation tailored to the Erythrae actually. And the excavation team and I reorganized the stones individually during that time. During that time, actually, I also measured the stones by photogrammetry while we were reorganizing them. And here we see Heroon and the not yet organized stone elements. This is laser scanning, and there are some scan positions on here. And this is the photogrammetry process, and these blue things are the camera positions, which were about 2070 70 camera positions had been taken. This is me. And this is the sparse point cloud, which I am going to explain now. And this is the dense point cloud. This is also for a stone. And this is the digitized version of the inventory sheet. And this, during that time, we also captured the material culture information, such as what kind of material have been used, the deterioration analysis, which were all parented by this inventory system. And the construction methodology, this is a hypothetical model of it. And this is the data entry form, which will be turned into database later on. I'm going to explain the second module now, which corresponds to data processing. On data processing, acquired data gets categorized, classified, and gets to be generated into information actually. With the help of this metadata, the heritage information is analyzed. Illustrated images here tells the story of metadata management part of the module. The 3D capturing methods result in formless digital results. They require to be organized. In the study, this main data type name is called point clouds. In here, I am showing how the georeferencing of the two separately generated point clouds of the Heroon is aligned, because we surveyed them with two different kinds of information, but digitally they gave us the almost exactly the same type of data, but they were not aligned or scaled. With that step, I had two sets of highly accurate representation of the Heroon. This is the correlation. I want to also explain the point cloud data. Point clouds are basically 3D points with texture and coordination data that mathematically represent the scanned or measured surveyed object with photogrammetry or another laser scanning or remote sensing methods. At the end of these studies, we all get point clouds. And the course of data processing, all 156 stone elements individually also processed, scaled, and respective orthophotos, the second metadata, are developed. Orthophotos are the rectified images of the photos, and they could be used for 2D drawings, or like in my study, we can use them as texture mappings. The aligned point clouds of the Heroon aided me to be able to 3D model the in-situ Heroon. This process resulted in highly accurate geometrical digital twin of the Heroon. You could see the modeling decisions and process here. My tests, which were failed. Also the winning methodology. Also the mathematical model type that I've used, which is NURBS model. I'm not going to get into them, but I want to highlight that there could be some kind of hypothetical models of the surveyed objects, heritage assets, but in this study we have quite highly digital twin of the Heroon. As I mentioned earlier, I 3D modeled the surrounding stones after the surveying process. The modeling is still based on the same mathematical system, which is called NURBS, but the process itself was different as seen on the image here. On this module, I also performed the information mapping of the Heroon remains with the help of the inventory system. Therefore, the information such as structural system, material culture, condition assessments from element to building scale have been three-dimensionally recorded on both the stones and these two remains. In the end of 3D modeling process, the Heroon and the stones have been digitally represented with heritage information and highly accurate reality-based 3D geometry. Now, I'm going to take a sip, sorry. I'm going to show the analyze part of the data processing module. Here we are seeing the materials of the elements in the remains. We couldn't do any non-destructive testings. These are pure empirical and theoretical studies, but the system works like magic when we want to change anything, so it'll work. Here we see the material types on both the stones and the stones in the in-situ building. And this analysis is the material deteriorations on the remains. And this is the structural system, such as masonry, typology, dowel system, or tooling, or detailing on the stones. And here we see the structural system damages. This is somewhat atypical analysis, actually, which is called positioning analysis. On this analysis, the stone elements have been categorized by their position, or we could say that their function on the building. With that action, the remains are prepared to be rationally ready for further study, such as restitution or digital anastomosis. The Heroon is situated on a private property, as I said before, that limited the excavation team, the research and work to only cleaning. Due to that limitation, I've tried to be focused on resolving constructional process of the structural system. Therefore, the temporal statements actually corresponds to the building and the replacement flow of their order. Sorry. Such as, I cannot name the temporal exact date of the phases, but from the architectural point of view, we can say which built first or at the same time. Here is the third module, information management. Up until this module, the process data and structured information is not yet to be relationally connected. What I mean by that, we only observed and recorded heritage information. On this module, I'll be showing the data-driven synthesis and safeguarding decision-making process. First, here we could see what kind of interpretations regarding the remains have been made, like moved stones, from the in-situ Heroon to the surrounding stone bundle. You could see the two types of building limitations, which will be helpful for me later on, here and there. And we could see this stone was as polia and such. These were synthesis. On this part of this module, we typically generate the ideas of the remains as built faces. And that is called restitution studies. These ideas could be represented as 2D drawings, 3D renders, and sometimes even not scaled illustrations, because they give us the idea of the building phases. The restitution of the Heroon is defined as seen in these images. With the help of early information from empirical studies and research, the Heroon's layout is suggested to have resemblance to the Megaron-based temple-like. Heroon's in-situ layout is about 7 by 11 meters, and which hinted that it could be one of the temple typologies that Vitruvius documented in his books, as in Antis-type Greek temple. Along with in-situ findings and Vitruvian information, the restitution of the Heroon has been represented here, which is quite hypothetical, yet we we had the opportunity to document the process with reliability source as well as decision formats, as you could see on these images. That transparency is along quite the proof of the data-driven conservation action process. Here we see the reliability degrees. We have shafts and capitals. For example, here we have a Doric stone block, and I tried to model that into restitutional position. And we have the cornerstone here, which showed us that this was not the limitation. The building was continuing, and we used proportions from the Vitruvian resources. And here we see the stones from the inventory quarry. We could, size-wise, we could put into the Institute Heroon. And here we see the highly hypothetical restitution with transparent reliability level. Along with the restitution studies, intervention decisions are generated following the data-driven principles as well. Here we see structural damages on the far left. Structural problems are first categorized in priority order regarding their severity. Then the application methods are systemized. That's decision-making network, which actually designed as an algorithm in the software, works according to the damage type and its severity, actually. For example, here we could see the primary damages in bright yellow, as selected here. And here there is the red. And we have this system for each structural problems. We have 3 priorities and 5 application methods. Here, I'm getting them there here fast. Okay. And here we could see the damages and intervention methods accordingly, actually. So we have a kind of algorithm behind this system, and it's 3-dimensional. I designed the same procedural system for the material deteriorations as well. In here, the algorithm has changed accordingly the level and became more tangled normally. Here we could see the deteriorations on the above right-hand side, and below that the intervention process with 3 main steps. Cleaning, consolidation, and maintenance. We also have a methodology for the consolidation as well, which I'm going to get into later on. Here we see all the material cleaning methodologies mapped here, the same as consolidation, and the application methodology for the consolidation. And here we see the maintenance decisions mapped on the model. Here we see the material deteriorations again. The 4th module is called curation. Curation has been used in museum studies or in IT industry for data curation and such, and that these are close but specific individual meanings in every field. Heritage curation is a novice approach for the dynamic management of the digital heritage knowledge, information, and data. Recent digital heritage management initiatives considers heritage curation as integrated part of an archaeological heritage management policy. In fact, Actually, in the form of architectural conservation process, it is rather a new concept. In present study, a workflow developed to utilize building information modeling BIM environments for the creation actions of the conservation process. First, I'd like to shortly explain the building information modeling, aka BIM, a little. BIM system is a digital information management system which mostly implemented for construction projects in architectural and engineering industries. BIM systems provide an extensive function for the construction process of the buildings. These functions vary from 2D drawings to operational management, monitoring of the building, or the building finance, controlling, scheduling the building finances even. Shortly, BIM fosters the virtual life cycle of a building or buildings. Although it is designed for the contemporary construction industry, since the beginning of 2009, heritage experts became conservational architects actually became interested in it. Now that is referred as heritage. Some people called it historical BIM as well, but now the literature more inclined into call it heritage BIM or HBIM. For the curation, stones and the Institute Heroon are treated separately on some levels due to their differences in 3D data structures. Here we could see the creation workflow of the Heroon remains. I'm going to explain it more clearly now. BIM environment has different information types according to the construction process. For example, a wall refers to a wall category in the system, but it is not that simple to define an archaeological building elements as solely as walls, or contemporary terminology or not always gives us the information of the archaeological buildings. In Heroon, we have a wall here, for example, but it is formed by individual stone elements that behave individually. That makes the BIM environment somewhat rigid, and the HBIM experts now trying to develop methodologies to get over that problem. And because BIM environment currently not directly employable, but I developed a workflow to provide that flexibility with the help of visual programming software. Here we could see all of the data to information and decision-making process for the stone elements. In Institute stones are also processed the same, but the integration part was different. Here we see the difference. I'm going to explain it later on again. Here we see the digitized inventory system, and we model them, we map them, and then we integrated them into the BIM environments with some visual programming, some simple algorithms used in that part. And this is the final workflow of the creation. Actually, we see the Heroon, the stone block. We all have the same workflow, and 3D modeling software, 3D models with information, not yet to be structured. At the same time, we have inventory system, digitization, and data entry, and we turn that into a database. Then this database metadata gets into the language of the BIM environment. At the same time, we have information modeling and mapping of the assets with some visual programming, some plugin. We have the HBIM. And if we change anything on that part or that part of the system, the system works simultaneously, just needs more somewhat powerful computer, but it works. Here is the data to information process documentation. This is actually the paradata of this part. We have the assets and the two different kind of 3D surveying methods, their alignments, and metadata managements, and the modelings. The data-driven conservation actions provided a solid workflow. Besides that, I also went through both national and international legislations and regulations. Before I finish the presentation, I also like to address two publications, regulation kind of publications. These are the London Charter, which is, if I'm not mistaken, is initiated in 2009 for the regulation of computer-based visualization of the cultural heritage assets, here we see. And the other one is the several principles for the virtual archaeology. London Charter has 6 articles, implementation, as you can see here, the highlighting concept of each article in here, and our studies, what is going on. Here see what we did in this project and how that correlates with London Charter. And here we see the principles of Seville. The civil principles is actually inspired from London Charter, but for the archaeological heritage. Here we see it's 8 articles, as well as with their highlights. And here our project on the left, what we did and which correlates to the articles matrix. Thank you for your time, and thank you, Arit, for this opportunity. I also would like to thank Erythrae excavation team and their generosity while working with them. It was great. Thank you all.